Today we are going to talk about how to draw ray diagrams for concave and convex mirrors. A ray diagram is drawn to determine the nature, the position and the size of the image when the object is kept at different positions in front of the mirror. Now, we have already studied the path of rays, and using these path of rays, we are going to draw the image. Please remember that to draw an image or to get an image, we need a minimum of 2 rays. 2 reflected rays should either meet at a point or appear to meet at a point. Now, the first position is the object is at infinity. When the object is at infinity, we will find that the rays coming from that object are parallel rays. So, you will find that I am going to draw the parallel rays. Okay, so the parallel rays, we need not draw the object. We are drawing just parallel rays parallel to the principal axis. And these rays after reflection, so I have got 2 rays. Okay, and these 2 rays after reflection, they will automatically meet at the focus. So this is the reflected ray and this is the next reflected ray. Okay, so these 2 reflected rays, they will meet at the focus. So these 2 reflected rays. Now they are meeting at the focus. So where is the image formed? The image is formed at the focus. Now what is the size of the image? The size of the image is highly diminished. Next, since the reflected rays are actually meeting at a point, the image formed is real and inverted. Now, next position is we are bringing the object closer to the mirror. Now, here we have got the mirror and we are bringing the object closer to the mirror. Now, in this case, we will draw an object. Okay, so I am going to draw an object beyond center of curvature. I will draw the object like an arrow mark so that I am able to know which is the top of the object and which is the bottom of the object. We are considering rays only from the top part of the object. Okay, so I can name the object as AB. So I am taking rays only from the top part of the object. Remember that there are rays from other parts, but I am not drawing it because my diagram will look very congested. So only from the top part. So the first ray, I will take the ray that is parallel to the principal axis. Okay, so touching the top of the object, the ray should go parallel to the principal axis. Okay, now this ray after reflection, it will pass through the focus. There is no other way that it will go. So it passes through the focus. This is reflected ray. Now the second reflected ray is also coming, incident ray is also coming from the top of the object, and I am taking the ray that passes through the focus. Okay, so it is passing through the focus and it is hitting the mirror. Now this ray after reflection, you will find that it is going parallel to the principal axis. So this ray is going parallel to the principal axis. So this is the second reflected ray. Now, where are the 2 reflected rays meeting? Okay, now this is the first reflected ray. This is the second reflected ray. If you want, I'll write over here. This is incident ray 1 and this is reflected ray 1. Okay, now next one, this is IR2, second incident ray, and this is RR2. Now where are the two reflected rays meeting? The two reflected rays are meeting here at this point. Now since I have considered rays from the top part of the object, the image of the top part will be formed here. Okay, so I find that the image is formed like this kind. I assume that there are rays from other parts of the object, but as I told before, we are not drawing but these rays are there. Okay, so I will find that the image formed is where? It is formed between the center of curvature and the focus. So between C and F. The image formed is smaller when I look at the object. So it is diminished. Again, the two reflected rays are actually meeting at the point, so you get a real and inverted image. Okay, so this is the thing. Please remember that the bottom of the image should touch the principal axis, because the bottom of the object is touching the principal axis. The bottom of the image should also touch the principal axis. Now, next position is I am bringing the object still closer to the mirror. Okay, now so the next position is the object is at the center of curvature. So again I am going to draw the object at the center of curvature. Okay, so this is the object at the center of curvature. Now what I am going to do is I am going again the first ray. Okay, the first ray I will draw it coming from the top part of the object and it is hitting against the mirror. So I will take this ray that is parallel to the principal axis. Okay, so I take the first ray parallel to the principal axis. After reflection, you will find that this ray passes through the focus. Okay, so it passes through the focus. Now, the second ray is going to come from again the top part of the object, and I can make it pass through the focus. So from the top of the object, I am making it pass through the focus. Okay, be careful about how you draw this diagram. Okay, and I'll going to draw the reflected ray. It goes parallel. You will find that if your diagram is correct, the two reflected rays are meeting right below the principal axis. Okay, so I've got the image. When the object is at C, you will find that the two reflected rays are meeting right below the principal axis. Okay, so this is RR2 and this is RR1. Okay, so these two reflected rays are meeting right below the principal axis and you get the image position at C. The size is same and the nature is real and inverted. Okay, continuing, I am bringing the object closer to the mirror. The next position is I am keeping the object between C and F. center of curvature and the focus. Okay, so here again I am drawing the first ray parallel to the principal axis. Okay, so this is the first ray. I'm making it go parallel to the principal axis, touching the top of the object parallel to the principal axis. Now this ray after reflection will pass through the focus. So it is passing through the focus. Now this is IR1 and this is RR1. There is no need for you to write this, but this is for you to understand. Next, I am saying the second ray, I am making it pass through the focus. So touching the top of the object and passing through the focus and hitting the mirror. Okay, so hitting the mirror. Now this ray after reflection, you will find that it goes parallel to the principal axis. Okay, so it is going parallel to the principal axis. So this is IR2 and this is RR2. Now where are the two reflected rays meeting? The two reflected rays are meeting here. Okay, and this point is beyond the center of curvature. So you will find that, see this thing. Now you can tell me, you can make assumptions about looking at this itself. You can understand that the image position is beyond the center of curvature, and because the two reflected rays are actually meeting, you get a real and inverted image. Okay, so here the object was between C and F. Now, next position. I am bringing the object, I am taking the object closer to the mirror again. And here I am keeping the object at the focus. Okay, so the object I am keeping it at the focus. So again I am drawing at the object at the focus. Okay, so as I said, please make sure, it would be nice if you can draw an object which is same size throughout. The same principle I follow. I draw the first ray parallel to the principal axis. Okay, so this is the first ray parallel to the principal axis. After reflection, what will happen? It will pass through the focus. So it is passing through the focus. Okay, so this is IR1 and this is RR1. Now, the second ray. Okay, in this case, since the object is on top of the focus, I cannot take the ray that passes through the focus. So I can take any other ray. Here I am going to take the ray that passes through the center of curvature. Okay, so touching the top of the object, passing through the center of curvature. Now what will happen to this ray? This ray, you will see, this ray is going to will retrace its path. Okay, so this is what is happening. The ray gets reflected back along the same path. Okay, I can extend my ray. So this is my ray and I am seeing that I am extending it. Here this is IR2 and this is RR2. Both are on the same line. Now what do you see about the two reflected rays? The two reflected rays are going parallel to each other. Now when rays are going parallel, we'll say that the rays will meet at infinity. So the image is real and inverted. Now the last position. Okay, the last position, I am bringing the object still closer to the mirror, and here I am keeping the object between the pole and the focus. Okay, so between the pole and the focus. I'll take the first ray, that is from the top of the object. Okay, the incident ray is from the top of the object and it is going parallel to the principal axis. Okay, after reflection, we know that it will pass through the focus. Okay, so the ray is passing through the focus. So this is IR1 and this is RR1. Next, the second ray, I can make it pass through the center of curvature. So let me just extend this. I can make it pass through the center of curvature touching the top of the object. Okay, as we told earlier, this ray will retrace its path. Please remember, the ray should pass through the center of curvature, should touch the top of the object and should hit against the mirror. Okay, so this is the ray. Okay, it retraces its path. This is IR2 and RR2. Now, in this case, we will find that the two reflected rays are not parallel to each other, but they are diverging. That means they will never meet. But if we look towards the mirror, these two rays are coming closer to each other. So, I will extend the two rays behind the mirror. Okay, so I am extending the two rays behind the mirror. So, keep your scale straight and extend the two reflected rays. Since it is behind the mirror, use dotted lines. Okay, because it is not actual rays, but they are just virtual rays. So here I am extending it beyond. Now, these two rays, I'll find that they are meeting here at this point. And I'm going to draw the image here. Now, since, as I told, it is formed behind the mirror, you are going to get the image formed is not the actual image, but it is a virtual image. Okay, and again, we'll say that the image is larger than the object. The position is behind the mirror. So, and it is virtual and erect. So, kindly keep in mind two things. Okay, as we are bringing the object closer to the mirror, the image starts moving away from the mirror. Okay, except in the last case. Then, next, as I am bringing the object closer to the mirror, the size of the image starts increasing. Okay, so these 2 points, please keep in mind and you will be able to understand ray diagrams very well. Thank you.